Water Resources Engineering 2, Unit 1, Gravity Dam. So, construction of gravity dam. So, gravity dams are constructed at right angle to the flow of water. So, before starting the construction operation of the dam, the water of river has to be diverted temporarily. So, water can be diverted by the two methods, that is the provision of or by the constructing of diversion tunnel or by constructing the dam in two stages. So, first method to divert water temporarily by the constructing of diversion tunnel. So, if suppose the topographical conditions are favorable, so diversion tunnel that can be constructed to carry a entire flow around the dam site, and the area in which the construction work has to take place is closed by the coffer dam. So, the diversion tunnel will start from the upstream of the coffer dam and will join the river again on the downstream side on the next to downstream of coffer dam. The other method for the diverting the water before the construction of the dam, that is by the constructing the dam in the two stage. So, dams sometimes constructed in the two stages. In such case, the flow is first diverted by the constructing a semicircle type of coffer dam. So, the construction work can be taken up in the water free zones. when the work in the lower portions of the dam on half of its length in one side of the river get completed. So, the remaining half width of the river is closed by a cofferdam. So, the flow is diverted through a dam outlet, or sometimes it may even be allowed to overtop the already constructed portions of the dam. So, the work will continue in the water free zone. For construction of dam, some following operations are adopted. The first one, that is the mixing of concrete. So, the heat of hydration must be less. So, this is the lean concrete mix. So, as it is dry lean mix of concrete in which the some percentage of fly ash is added. So, it generates less heat of hydration during its setting and thus result in less shrinkage and cracks resistance concrete. And after the mixing of the concrete, then placing the concrete and compacting of concrete. So, now here use some vibratory roller, and then comes to the curing of the concrete. So, here the curing in two stages. The first is pre-cooling and the other is the post-cooling. So, in first in the pre-cooling, the concrete is pre-cooled before it is placed in the dam using refrigerated water for the mixing, or by cooling the coarse aggregate by the spraying the refrigerated water over it, so that it will take some heat of hydration. In the post cooling, so now this post cooling is achieved by circulating refrigerated water through the pipe embedded in the concrete in each lift. Joints in concrete dam. So, to reduce the thermal stress and subsequent cracking in the body of the dam, so most of concrete dam are provided with joints. These joints may be grouped in the two categories. The first is the construction joint and other is the contraction joint. So, now in construction joint, these joints are also known as horizontal joint, because the entire work of concreting in the whole dam cannot be completed in one stretch. So, the concreting is therefore done in various stages. So, it is necessary to provide joints during construction to execute the work systematically and economically in stages. So, in solid gravity dam, the height between the joints is usually limited to about 1.5 meter. This height between the two successive construction joint or horizontal joint is known as lift. So, for first layer immediately on the rock, the thickness of the lift may kept half So, usually the height of the lift is taken as a 0.75 meter. The other one is the contraction joint. So, this type of joints are mainly provided to avoid cracks caused due to shrinkage of concrete due to temperature changes. So, contraction joints are of the two types, that is the transverse joints and the other is the longitudinal joints. So, in the transverse joint, the transverse joint are provided normal to the dam axis. So, the function of this joint to prevent the transverse crack due to contraction of the concrete. So, the usual distance between two transverse joints is kept as a 15 meter, and these joints are extended through the entire structure. So, in order to make the joints, here is providing the watertight and keyways or the water stops are provided in the transverse joint. So, the keyways, the function of the keyways to transfer the shear from one section to the adjoining one, and thus make the dam behave as a monolithic. So, vertical keys in transverse joints are used to transfer the horizontal shear, whereas horizontal keys in longitudinal joints are designed for the vertical shear. So, it may be in either in the triangular in shape, either or in the rectangular or the trapezoidal in shape. Now, in water stop, this water stop of either metal or the synthetic rubber or plastic or that is the PVC, means polyvinyl chloride, are placed in vertical, that is transverse construction joint near upstream face to prevent the leakage of water. Sometimes the asphalt stops are also used to allow for very small lateral movement of this joint. the longitudinal construction joint. These joints are provided parallel to the axis of dam to prevent longitudinal cracks. So, longitudinal joints run between two adjacent transverse joints and are thus not continuous in vertical plane, and dividing the dam into the number of block. So, the spacing of longitudinal joint is limited to 15 meter. So, then at a time the construction of the concrete in one stretch, that is 15 meter for the transverse, 15 meter for the longitudinal, and 1.5 meter for the construction. So, at a time the concreting is done for a block of 15 meter by 15 meter by 1.5 meter. Galleries in gravity dam. So, galleries are the horizontal or the sloping opening in the body of the dam. They may run longitudinally, that is parallel to the axis of dam, or transversely, that is normal to the axis of dam, and are provided at various elevations. So, all the galleries are interconnected by steeply sloping passages or by vertical shaft fitted with the stairs or the mechanical lift. The function of galleries. So, the galleries are provided for the following purpose: to provide facilities for drilling and grouting operation for foundation, and to drain off the seepage water through the body of dam, and to provide space for header and return pipe for post cooling of concrete and grouting the longitudinal joints after completing the dam, and to provide access of dam interior for the inspection. the types of galleries. So now here are the two types of the gallery, that is the foundation gallery and other is the inspection gallery. So in foundation gallery, that is also called a drainage gallery and used to drain off the water which percolates through the foundation. So the seepage of the water take place through the foundation from the upstream side of the gravity dam to its downstream side, exert uplift pressure that reduce the effective self weight of the dam. So this uplift pressure can be relieved by drilling drainage hole through the inspection galleries to a sufficient depth into the foundation. So these relief drains are placed little downstream of the grout curtain, and they are usually 7.5 to 10 centimeter in diameter and spaced, that is the 5 meters center to center. So these foundation galleries are provided, that is for the space for the drilling holes, for the providing the grout curtain, and the size of this is the 1.5 meter by the 2.2 meter or 1.8 meter to 2.4 meter. So 1.5 or 1.8, that is the width, and this 2.2 or the 2.4, that is taken as a means height of this foundation gallery. Inspection gallery. So the purpose of the inspection gallery is provided for the inspection purpose. So as this gallery is to be provided into the body of the dam throughout its entire length, adequate provision for its ventilation and illumination should be made. So very large dam may be provided with more than one gallery situated at the different levels and running parallel to each other for better or for giving the some slopes and effective control of the seepage throughout the body of the dam. So they provide the some enough space for also the pipes for the post coolings, as well as they provide the some access to the dam interior for the observing purpose and controlling the behavior of the dam. The shape of gallery, the gallery is usually rectangular or in oval shape with top and bottom, either it may be the flat or the semicircular. And also at its corner should be the rounded width and width of the gallery is taken or vary from the 1.5 to 1.8 meter, and the height of this gallery is vary from the 2.2 to 2.4 meter. So then the person can easily walk inside the gallery. foundation treatment. The purpose of the foundation treatment are to prepare stable support for the dam and to safeguard against sliding and to safeguard against uplift and water creeping through the junction of the dam and foundation. So, for the stable support and the safeguard against sliding to prepare or the preparation of this surface. So, surface preparation consists in removing the entire loose soil till the sound bedrock is exposed, and the excavation should be carried out in such a way that the underlying rock is not damaged and the final surface obtained above is stabbed, so as to increase the frictional resistance to the dam against sliding, and also some shear key maybe sometimes be provided at the heel. So, then means reducing the means the sliding or means form some stable support, and the toe is always higher than the heel. And safeguard against the uplift. So, then the foundation grouting can be done or it can be divided into the consolidation grouting and curtain grouting. So, the first is the consolidated grouting. The entire foundation of the dam is consolidated by grouting. For this, shallow holes are drilled through the foundation rock. The depth of these holes generally vary between 10 to 15 meter, and they are situated at about 5 to 20 meter apart. So, after the holes has been drilled, a mixture of cement and water, that is called grout, is forced into the holes at low pressure of about 300 to 400 kilonewton per meter square, or now you can say 30 to 40 Newton per centimeter square. This is accomplished before any concreting of the dam section is laid. These low pressure grouting holes will later serve the purpose of a cutoff against leakage of high pressure. So, grout which is to be used after the some concreting of the dam has taken place. So, means whole foundation due to this low pressure of grout that can be the consolidated. So, then reduce the CP. To safeguard against uplift, now here is providing the some foundation grouting by the consolidated grouting and curtain grouting. So, consolidated grouting already discussed in previous presentations. So, in curtain grouting, now it helps in forming a curtain against the seepage through the foundation and thus reduce the uplift pressure. For this, relatively deeper holes are drilled near the heels of the dam. So, the spacing of the holes may vary from 1.2 meter to 1.5 meter, and Now, these holes are first of all drilled and grout at about the 10 to 12 meter apart, and then intermediate holes are drilled and grouted. The depth of the holes are vary from 30 to 40% of the total upstream water head for strong rock foundation, and it may be as much as the 70% of the water head for the poor rocks. So, after the holes have been drilled, a mixture of the cement and water is forced into the holes under the high pressure. So, this grouting may have to be accomplished from the foundation galleries within the dam. So, it may also be done from the upstream face of the dam if possible. So, after completing this theory portions of the gravity dams, now then comes to the stability analysis. So, this stability analysis of the gravity dams may be carried out by these two following methods, that is the graphical method and other is the analytical method. So, graphical method is also said to be, that is the steps step by step method. Now, before comes to the stability analysis, now here is comes to the some assumptions. So, now here is the three main assumptions are summarized as the first one is there is no load transfer by beam action, as the entire dam is assumed to be composed of series of vertical slices or cantilevers, and the material of dam and foundation is homogeneous, and the dam and foundation acts as unit, and the foundation is static, and there is no over stressing of the materials of the dam and foundation. analytical method. So, the stability of the dams can be analyzed by the some steps here for a unit length of the dam and compute all the forces acting in vertical as well as horizontal forces. So, that is the summation of V means vertical forces as well as the summation of H. So, this is some algebraic sum of this horizontal forces. So, this is the summation of H, and calculate the moment of all the forces acting on the dam about the toe and determine the sum of overturning moment means disturbing moment. So, this is the summation of M d, and also the sum of righting or restoring or the resisting moment, that is the anticlockwise, summation of M r, and find the algebraic sum of summation of M r and summation of M d. So, that is the summation of M is equal to summation of M r minus summation of M d, and find the location, that is the distance x bar, or now we can say this is the x of the point of intersection of the resultant force with the base from the equation. So, x is equal to the summation of M upon summation of B. So, now here consider only the 1 meter length of the dam and determine all the forces, means summation of the B and summation of H in vertical as well as in horizontal direction, and take the moment of all the forces about the toe. So, the clockwise movement that will give the disturbing moment, and anti-clockwise movement that will give the resisting moment, and find out the summation of M is equal to summation of M r minus summation of M d. Then find out the location of this resultant force from the at a distance from the toe. So, this x is equal to summation of M upon summation of B. Then calculate the distance of the eccentricity E of the resultant force R from the center of base of the dam. So, E is comes out the B by 2 minus x. So, where B is the base width of the dam, and this E must be less than the B by 6. So, then there is no tension developed anywhere in the dam, and calculate the value of normal stress, that is also known as the vertical stress at toe and heel. So, P b maximum for the toe and P v minimum for the heel. So, for the maximum, the summation of V 1 plus 6 E by B. So, this is the P v maximum, and in P v minimum at the heel, that is the summation of V by B 1 minus 6 E by B. So, this is comes out the P v minimum at heel, and compute the principal and shear stress developed at the toe and heel of the dam by making use of these equations. So, sigma, that is the principal stresses, is equal to P b sec square alpha minus P dash tan square alpha. So, this P b now to find out this the principal stresses at the heel. So, then the P b is used at as a toe. So, means P b maximum, and P dash, that is the tail water pressure, and the shear stress means tau 0 is comes out the P b tan alpha. So, this P b used if the stresses is find at the toe, so that PV that is used maximum, and stress is find at the heel, so this is used as a PV minimum. And determine the value of factor of safety for the different mode of failure, against mode of failure, by overturning, by sliding, as well as find out the stresses and shear friction factor. So then the factor of safety against overturning, that is the FOS. So summation of the righting moment, that is the anti-clockwise moment, or that is also known as the resisting moment, and divided by the summation of MD, means overturning moment. So this is the negative moment, or now you can say this is the clockwise moment, and that should be comes more than the 2 or the 2 to 3. So then the dam is the safe against overturning. Then determine the factor of the safety against sliding. So now here is used, this is the factor of safety against sliding, that is the ratio of the frictional resistance to the horizontal forces. So the frictional resistance that will comes out the mu times of the summation of the V, and horizontal forces means summation of the H. So that should be more than 1, then the dam is the safe against sliding. Now in large dam, now here is also the used some shear friction factor, SFF. So now use some the strength of the joint at the different planes or the levels. So SFF is equal to the mu times of the summation of the B plus B into Q. So Q is the strength of the or the shear stress of the joint, and that will vary from the 1400 to 4000 kilonewton per meter square according to the conditions of the rock. So that should be the more in between the 3 to 5. So this analysis should be carried out for the reservoir full case as well as reservoir empty conditions. So this is the complete portions of the theory as well as the theoretical part of the Gravity Dam, as well as knowing means how to check the stability of the dam and how to design this Gravity Dam. So now after this presentations, now we will discuss about some numerical solutions. So how to find out the different forces on the Gravity Dam, or how to find out some different factor of the safety for the some failure mode of the Gravity Dam, as well as the stability criteria of the Gravity Dam. So thank you very much. So you have any problem, so you can contact me at any time. Thank you very much. So now in the next presentation, now we will discuss about some numerical part of this unit. Thank you very much.